Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.110. While solving this problem, we will be using delta connection to star connection conversion. Here is the list of formulas which is used to convert a delta connection into an equivalent star connection. Now move towards the problem. Exercise problem number 2.110. Find the value of voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network we have to find the value of voltage V0 across this 6 kilo ohm resistance. So without wasting time, let's proceed towards the solution. So in order to calculate voltage across this 6 kilo ohm resistance, we should have the value of current through this resistance. In order to calculate current through this resistance, we have to simplify the network. We will start simplifying this network from this end. This is a delta connection, and in order to simplify the network, we have to convert this delta connection into equivalent star connection. For that purpose, we will place a star connection inside this delta connection and will use these three equations to calculate equivalent resistances in star connection. Resistances of star connection RA, RB and RC are required to calculate, while the resistances of delta connection are labeled as R1, R2 and R3. These resistances will be used inside these equations to calculate respective RA, RB and RC. So we will start calculating from RA. For that purpose, the product of R1 and R2 will be taken and it will be divided with the sum of all resistances connected in delta connection. So solving this equation, we will get 6 kilo ohm resistance of RA. Similarly, RB will be calculated and the value of RB will be 2 kilo ohm. RC will also be calculated using this equation. In this equation, the product of R1 and R3 will be taken in numerator, while 18K plus 12K and 6K will be taken in denominator. By solving this equation, we will get the value of RC, that will be equal to 3 kilo ohm. Now we can replace this delta connection with star connection for further solution of the problem. So we will modify the network by indicating resistances of star connection and replacing delta connection with star connection. At this stage, these two resistances are converted into series connection, so we will find their equivalent resistance and replace that equivalent resistance of 6 kilo ohm with these two resistances. So the circuit will further simplify. Now in order to calculate current through this resistance, first we have to simplify the network and calculate total current through this branch. If we succeed to calculate current through this branch, then we will apply current divider rule to calculate current through this branch, and later on we will be able to calculate voltage across this 6 kilo ohm resistance using that calculated current. For that purpose, first we have to simplify the network to calculate total supplied current. If we observe, these two resistances are connected in series connection, so their equivalent resistance will be equal to the sum of both resistances, that will become 12 kilo ohm. Now the equivalent resistance of this series network, that is 12 kilo ohm, will be parallel with this 6 kilo ohm. So we will find their equivalent resistance by taking the product of both resistances dividing by their sum. So the equivalent resistance of these two resistances and this resistance will become 4 kilo ohm, and this 4 kilo ohm will be in series with this 3 kilo ohm resistance. So total resistance of the network will be the sum of 3 kilo ohm and 4 kilo ohm, that will become 7 kilo ohm. After calculating the total resistance of this complete network, we can calculate total supplied current using Ohm's law. Current I will be equal to 12 volt divided by total resistance of the network. It will become 1.71 milliampere. Now this total supplied current will be flowing from this branch and it will be distributing among these two branches. And the direction of current will be upward, leaving from positive terminal and entering towards negative terminal. So modify the network by indicating current through this branch with its direction. At this stage, we can apply current divider rule to calculate current through this branch. For that purpose, we will use this equation. We are assuming current through this branch is I0 and the value of current will be equal to R2 divided by R1 plus R2 multiplied by total current. In this equation, total current is 1.71 milliampere. R2 is the resistance of opposite branch, that is 6 kilo ohm, and R1 is the resistance of same branch, that is the sum of 6K and 6K. So place values inside this equation. Equation of current I0 will become 6K multiplied by 1.71 milliampere divided by the sum of 12K and 6K. Solve this equation to calculate the value of current I0, that will become 0.57 milliampere. Now we have the value of current through this branch. Value of resistance is already given, so we can calculate voltage across this 6 kilo ohm resistance using Ohm's law. Product of resistance and current. Here the current is taken with positive sign because the direction of current through this branch will be clockwise direction and this current will be entering from positive terminal. That's why this current is taken with positive sign. Take the product of 6 kilo ohm and 0.57 milliampere. It will become 3.42 volt. So the value of voltage across this 6 kilo ohm resistance is 3.42 volt. So this was exercise problem number 2.110. Thank you. See you again in next video.